Okay, so this is our formula for integrating by part, which is integral of u dv equal to uv minus integral of v du. But one of the issues that we have in calculus is like what should be our u and what should be our dv. Fortunately, the Lipit methods, which is really an acronym uh, uh, that is helping us to select our U and DV. So let's look at the acronym first, and then we will know how to use it. So L stands for logarithmic functions, and I stands for inverse trigonometric functions. P stands for polynomial, and E stands for exponential function, and T stands for trigonometric functions. So what this acronym is saying is that, or Lipit method is saying is that whenever you see logarithmic functions such as like lnx, which is a natural logarithmic function, that is going to be a u. Whoever has the acronym is going to be your u. The rest of the integral is going to be your dv. That's it. So if you see a log like lnx or log base to something, that is going to be your u. Number two is inverse trigonometric functions. What are those? Those are like sine inverse, cos inverse, tan inverse, etc. And number three, the third place is polynomial, like x squared, x cubed, x to the fourth, etc. And number four is exponential function. What are exponential functions? Such functions like 2 to the x, 3 to the x, 5 to the x, or e to the x, a very important one in calculus, natural exponential function. And last place for u selection is going to be trigonometric function like sine, cosine, tangent x. So now you know that you're always going to, that's going to be your last choice. So let's now go ahead and do one problem, see how it works with Lipit. Okay, so we are given an integral ln x dx. Go ahead. See if you could make the u selection based on Lipit method. Okay, so remember that L stands for the first letter. That's if whenever we see L, that comes first. So that ln x is natural logarithmic function. So that's going to be our u. So that's going to be a u. The rest of the integral, which is 1 dx, is going to be our dv. Now we are differentiating with respect to u. You get the u and then ln x, which will give us 1 over x dx. And then integrating on the right side. So the integral of the dv is just v, integral of dx is just x. I just want to show you one second what we are doing on the right side. We are integrating because you're given the derivative. Remember that? You're given the derivative. So to get back the function, you have to integrate them. Integral of dv, 1 dv is just v, of course, plus c, and then 1 x plus c. But we don't worry about the x because at the end we're going to add a constant. So the sum of a constant is still a constant. Okay, now we're almost done. So all we have to do is use the formula. But I just want to make a point here. I always tell my students to make this pattern, okay, to just be more organized. And so it's a cross that is telling you on the left side are the derivative rights, or the right sides are the integrals. But let's go ahead and use the formula. So we have x ln x, which is really our uv minus, okay, so remember that that's uv x ln x minus v du. That's the formula we're just following. And now at this time we see that we can simplify something here. So let me get this color, and we are just crossing x with x, and now we are left with x times ln x minus integral of 1 dx. And then from there on, we write our last step, which is really x ln x minus integral of 1 is just x plus c. And we're done. Okay, ready? Let's do the second problem with Lipit. All right, in this case, we have a polynomial, okay, and we have an exponent. Clearly, whoever comes first, that's going to be our u. So let's look at it. Polynomial, that's a polynomial, and that's our exponent. So you see that polynomial in Lipit is first. In our polynomial has third place and exponent has a fourth place. So clear winner, we have a clear winner, no doubt about it. It's going to be u is going to be the power or exponential function. So u is going to be x. The rest of the problem, the expression inside the integral is going to be our dv. So we have our u is going to be x, our dv is going to be e to the x dx. Now doing exactly what we did last time, differentiating u gave us du, differentiating x gave us dx, integrating dv gives us v, integrating e to the x gave us e to the x, plus a constant. Now we're done, and we're going to write our formula, and let's label them u dv, okay, that's the formula, is equal to uv. Now remember that uv goes like this. Let me just write this down. We're just going to do uv. We're going to multiply these two all the time, uv. So we have x e to the x, and then we are multiplying it v du, uv minus v du. So v du, so that's your v. Okay, v du. So that's what we have to do. It's like that. Okay, and once you're done with that, all you have to do is simplify it. So you can see that you bring down your x e to the x minus also down, and the integral of e to the x is just e to the x plus a constant, because we're missing the limit of integrals. The lower limit is missing and the upper limit is missing. It's an indefinite integral. Okay, we're done with the second example. Let's try one more example with Lipit method. Okay, this time I'm not writing the Lipit, so hopefully you memorize them. So we have a polynomial and a trigonometric function. Of course, t is at the t is the last alphabet in acronym Lipit, so we're gonna do that last. So again, your polynomial x wins. Okay, so congratulations, x. All right. So I always want to make this pattern cross, and I write my u and I write my dv. The derivative of u is du, and the derivative of x is dx. The integral of dv is v. The integral of sine x is minus cosine x. Minus cosine x. So when you do in the integration. Now we're ready to go and write our formula. Okay, so let's look at it. We have u dv is equal to uv. Again, cross multiply x times negative cosine x minus, which comes from the formula, integral v du. V is negative cosine x and du is just dx. Very simple. Let's go back and simplify. So we can write x times negative cosine x minus x cosine x, and negative become positive, and the integral of cosine x we have to do that. That's the next step. So we bring down the negative x cos x, and the integral of cosine is simply sine x plus c. So this is really helpful method. The reason for this one was to show you that that we could use the acronym rather than guessing, And I hope this helped you, and see you in the next presentation. Thank you.